All right, guys, we're going to finish studying chapter 4 with section 4.4, graphing, cosecant, and secant. And the key to these is knowing that these are reciprocals to sine and cosine. So if you can graph sine and cosine, we are going to be able to throw this down fairly easily. Now, let's just graph the basics first, and we'll get some philosophy as we go, and then we'll look at graphing some more advanced ones. If I want to graph y equals cosecant of x, what I must remember is that cosecant is the reciprocal of sine. So the first thing I want to graph is actually sine of x rather than cosecant. Well, now sine of x is something we have been graphing for quite a bit of time. We know it ranges typically from 0 to 2 pi when it's just a plain old sine. I'm sorry, that's its period, and then it ranges from 1 to -1. So if I wanted to graph this, sine is typically 0 and 1 and 0 and -1 and back to 0. So it would look something like this. Now we don't normally extend these, but remember, these do extend out. We could just keep on drawing them. Well, I didn't exactly do that one right, but let's see if I can fix these real quick to make them actually go out the way they're supposed to. We could draw these out and keep on curving them. Right, so there is sine of x in blue. Now, cosecant is the reciprocal. So let's just take the fact that we have the point 0, 0 on sine. That's the first point. That's right here at this red. If the y value, if sine of x is equal to 0, that is 0 over 1, then cosecant of x would be the reciprocal of that. That is 1 over 0. But we know that this is undefined. Well, what happens at a place where a function is undefined? We get a vertical asymptote in this case. Not always, but in this case. So everywhere where sine is 0, I'm going to have cosine with a vertical asymptote. And I'll show you what that looks like. We just draw typically a dotted line down the place where sine is 0. Now sine is also 0 here. So along this part, I would also have a vertical asymptote. And here, along these, I would have a vertical asymptote. And again here, still a vertical asymptote. All right. Now, it's the reciprocal. But if you take 1 and you reciprocate it, you're going to get 1. So these points where we're 1 and -1, they're going to be the same. And then you're going to have to just trust me on it. You could go through the t-chart, but this will turn up, always turning in the opposite direction of sine. These will turn down. And so what we have is cosecant of x is graphed in red. So we just put down sine to start with, and then we worked from cosecant from there. Right, let's repeat that process with secant. Right, again, if you're going to graph secant, you must first graph the complementary cosine. So 0, pi over 2, pi, 3 pi over 2, 2 pi. And cosine ranges from 1 to -1. So it starts at 1 and then goes to 0 and then -1 and then 0 and then 1. So it comes off nice and smooth like this. But remember, it also extends out. So if you wanted to have an actual continuing curve, that's what it would look like. Now secant, for the same reason as sine, wherever cosine is 0, will have vertical asymptotes because it will be undefined at that point. Okay, these values will remain the same, but the other ones will be the reciprocal, so they will flip in this fashion. And so the red is actually the graph of secant. What I did for secant and cosine's basic is I graphed sine and cosine, and then I put down the asymptotes, and then I used those key points and flipped up the other values. Okay, so how does this work with something that's being changed? Well, it's going to work similarly. What I want to graph here is all of the same stuff but in reference to sine first because cosecant and sine are the same. Now recall from our learning about graphing sine, the first thing you need to do is to find an accurate shift on this, or the period that you need to be working with. If I added pi over 2 to both sides, that would give me pi over 2 to 5 pi over 2. Well, if this is 0, pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, and 5 pi over 2. Pi over 2, 2 pi over 2, which is pi, 3 pi over 2, 4 pi over 2, which is just 2 pi. And we typically go from 1 to -1. Now this sign has an amplitude associated with it. So instead of my typical 0, 1, 0, -1, 0 for sine, I'm going to have to multiply that by 2. So I would still have 0, and then 2, and then 0, and -2, and 0. So that is what I will plot in reference to this one. So this would be 0, 2, 0, -2, and 0. Now remember, these come on back to these different locations here. You can complete them to get a good look at what is going on, okay? Now, wherever sine is 0, we're going to have these asymptotes. And then these points are still going to be in common. You're taking care of all that shifting for cosecant. So cosecant is in red. So very simply, you're going to find first your sine, as we normally would, and then we lay down those asymptotes, pick out those key points, and flip those values up and down as appropriate. All right, let's do one more. Again, hopefully this is old hat for you. This is secant, so I need to rewrite this as cosine. And this was a very advanced one. It has all of the stuff included in it. So I'm going to put my 1/2 x minus pi between 0 and 2 pi, and I'm going to solve this for x. I'm going to add my pi, and then I'm going to multiply by 2. Okay, so it gives me 2 pi up to 6 pi. I think I'm going to have to make these rather squished, but that's okay. This would be 1 pi, 2 pi. Oh, let me see if I can make this 1, 2, 3, 4, 5, 6. So this is 6 pi. This is 2 pi. And I'm going to be in here working in here. So in between there would be 4 pi. And then of course 3 pi and such. And I'm not going to label those because we would just get too tight on space. Now I'm going to still mark these up 2, 3, 4, and mark these down as we normally would, just to try to stretch this graph out a little bit as we're going. Now cosine typically is 1, 0, -1, 0, and 1 is their key points. And again, I'm focusing here, focusing here. I've taken care of this part. Now I need to multiply by the amplitude and add 2. So if I multiply this by the amplitude, I would get a fourth. Let me do that a different color so we can just see what was going on. A fourth. This would be 0. This would be -1/4. This would be 0, and this would be 1/4. I applied amplitude. Oop, amplitude. Okay. Okay. Now I want to go ahead and add that 2 additional. So if I add 2, I'm going to get 2 1/4, and 2, and 1 3/4, and 2, and 2 1/4. So I'm ready to plot those. I'm going to plot them in blue. At 2 pi, remember that's my start zone right here. This is where I'm graphing. At 2 pi, I'm going to get 2 1/4. 2 1/4 is going to be right in here. And then at 3 pi, I'm going to get 2. At 4 pi, I'm going to get 1 3/4. At 5 pi, I'm going to get the 2. And at 6 pi, I'm going to get 2 1/4. Now remember, this is going to keep on fashion. Oops, sorry, a little bit too high. So that this little graph is smoothing out through here, just like this. Now, the question arises, where are my zeros? Where is my zero? Now, you need to think about that amplitude, that horizontal line. What you've done is you've shifted your line up. So wherever it's hitting that 2, okay, where it's that middle line, that is where your asymptotes are actually going to be. All right, and I could keep on going if I needed to. So here's my key point. This is going to turn down. Key point, going to turn up. Key point, going to turn down. Key point would turn up. So in the red, I have secant pulling off of cosine. So the one thing that may be odd here is my 0 points were at the y equals 2 level. Okay, that's what my new line of horizontal reference would be because I shifted this whole thing up to. All right, guys, I hope that that's helped you with secant and cosecant. We will try to pull all of it together on Monday, but that will give you some homework time. Remember, if you're just doing multiple choice questions, that's not good enough. You really need to be in your book and drawing these by hand as you go. Okay.